Hello everyone and welcome back to my channel. So basically we are going to continue our Kubernetes series in this particular video. In the previous video we understood what is kubeconfig file and how is it important for us, right? Now in this video we are going to talk about Kubernetes pods. So what are pods? This is something that we are going to understand. We are also going to understand why are they required in the first place when we already have containers, right? Then we are going to understand the pod lifecycle. Then we are going to do some hands-on on creating your pods and deploying them on our Kubernetes cluster. Okay, so there are multiple ways through which we can create our pods also. We are going to look at that as well. Okay, so we are also going to learn about how to write manifest files for our pods. Okay, so we are going to cover the basic concepts in this particular video. For the more complex topics like init containers, sidecar containers, and pod affinity and anti-affinity, we are going to cover these topics in the coming lectures. I don't want to keep this video very complicated, right? So for that I kept it a bit easy to understand for the beginners. Okay, and in the coming lectures we are going to cover all of them, so don't worry at all. Okay, so without wasting any time, let's get started. So the first thing that we need to understand is this, that what is a pod, right? So basically a pod is nothing but a smallest deployable unit within our KTS cluster. Now what does this mean? So basically, whenever we deploy an application within the container, we deploy it using Docker. We first build the image using Docker build, and then after that we execute this command, that is docker run, in order to run the container, right? But the problem with this container is that it can stop anytime, and in the production we can't directly make use of containers, because if our application is being used by our users and suddenly this container is not working, then it is going to cause a lot of loss in terms of business, because your application has suddenly stopped working, right? So this is not going to help us in the long run. So the solution was Kubernetes. Why? Because it helped us manage these containers in order to manage these containers and keep them available or restart them if they are not if they suddenly stop. There needs to be an action that needs to be taken, right? So for that we need Kubernetes, and in order to manage these containers needs to be packaged as a pod, because Kubernetes can manage a pod, and pod contains the container, right? So this is the hierarchy within the Kubernetes. Okay, so pod is nothing but just a unit which contains a container, so that Kubernetes can manage your container. It can apply different objects on it in order to manage it, right? So this is possible only with the help of pods, because pod is the smallest deployable unit. Okay, so I hope this is a bit clear. I explained it in short because it is very easy to understand as well, right? So this was all about the pod. What is a pod? Now, the next important thing is that a pod can contain one or more containers. It is not necessary that it should have only a specific number of containers. It's not like that. It can have any number of containers. But the most important thing is that we only keep one pod per container generally for the simplicity. But there are some use cases where we require multiple containers in the same pod. So these cases are different, where we make use of sidecar containers. So I'm not going to cover about anything related to sidecar container in this particular video, but in coming videos we are going to cover this, so don't worry. Okay, so generally a standard practice is that one pod per container, that's all. Okay, so this is what is about the number of containers that we have inside our pod. Now, these containers that are present within the same pod, they have got a same network. They are present within the same network. They can also share volume mounts. They can connect with each other just with the help of local host, since they are present on the same system, same pod. So a single pod has got a single network, right? And within that network, suppose this is my pod, okay, and within that pod you have, let's say, two containers. Let's say C1 and C2. Now, if this container is running on port 8080, this container should not run on port 8080. It should be running on any other port other than that, because it is similar to running containers on the same host, right? So if on your computer, if you are trying to run two different containers, then these containers should not be running on the same port, because it will create a conflict. So similarly, it happens within the pod as well, because a pod is serving like a host, a single host for these two containers. So that's why they can communicate using these two different hosts, like local host colon port. They can communicate with each other in this particular way. Okay, if the containers are in the same pod. In different pods, then the scenario is different, because the IP address will be different. Just give me a second. Okay, so now the other important thing that we need to cover is that every pod has got an IP address allocated to it. You will see this in the coming part where we are going to create a pod. Then you will see a specific IP address allocated to it. Okay, so this is one thing related to pod. So the next thing is that the pods can communicate with each other using these IP addresses. Okay, since each pod has got a separate unique IP address to it, they can communicate with the help of the IP addresses as well. Okay, and the next point is this, that these pods are ephemeral in nature, which means that they can be created, they can be updated, and also deleted. And once deleted, all the data that is present within your pod gets vanished. So we can't just simply deploy our applications even in pod. So there are other objects which are required in order to create these pods. Okay, to manage these pods, we require another objects within Kubernetes, and those objects are like deployments. You must have already heard them. Deployments are there. Replica sets. We also have got stateful sets. So in different scenarios, we make use of different objects. Okay, so in order to manage our pods, but individual deployment of pods within production is not recommended at all due to the ephemeral nature of pods, because all the data will be gone. If you have your application running on your pod and suddenly someone comes and deletes it, or if someone comes and deletes it, or it gets deleted, or it gets destroyed due to some sort of an error and it fails and it gets deleted, then what else? Then what is the solution to that? So in that case, we need these other objects which help us maintain the number of pods. They also help us save this data as well in case of stateful sets, which are basically used for the databases. The next important thing is that all the containers on the same pod are scheduled on the same node. Same pod, same node. Okay, so basically a pod is like a single host, and on host you are hosting multiple containers. So they are basically actually executing on a single physical node. Okay, so this is an important thing. Another thing is that you can also set or request CPU and memory requirements for the containers running on the same pod. Okay, so you can also request for the CPU as well as memory that is required for your container to execute, so that that much amount of resources are allocated for that specific container on the node. Okay, so this is how you can allocate some sort of resources for your containers within the pod. Okay, so this was an overview, okay, of what pods are. I hope this was clear. Now the next important thing that we are going to cover in this particular video is about the pod lifecycle. So pod undergoes multiple stages. When it gets created, it undergoes different stages. So those stages are something we are going to understand, and what actually happens in the background with respect to each stage is what we are going to study. Okay, so let's try to understand the life cycle. Okay, now whenever you create a pod, the first stage that it goes into is a pending stage. Okay, so this is the stage in which your pod generally goes. Okay, so in this stage, what happens in the background is that it is looking to schedule itself on the node of the Kubernetes, and of course it is a worker node. So your all the workloads that we are going to deploy as a user are going to go on the worker nodes. Previously we understood the control plane as well, right? So we as a user generally don't deploy our applications on control plane. So it is specific for the controllers, schedulers, then API server as well as etcd. So those pods are actually running there and they are managing the entire cluster, right? So basically the scheduling part is going on when actually it is in the pending state. One thing. The second thing is that we mention the image within our containers for our pods to be created. So we don't actually pass the containers. What we do is we pass the image, and with the help that image is being pulled, right? And then once it is pulled, it is actually executed. And once it is executed, the container actually runs, right? So for running a container, we have got the container runtimes present on our worker nodes, right? And this is the image that is being pulled. So in this stage, these two are the most important things that are happening in the background. Okay, so once the image is pulled and once the pod gets scheduled on a specific node of your Kubernetes cluster, it goes into running stage. So in this stage, you are ready to debug the logs. You can also port forward your pod in order to access it. And mostly it is done for the testing purpose. Port forwarding is something that's not done on production. Okay, so you will get to know this as well. We are going to do this also in our hands-on session, so stay tuned. And the next stage is about succeeded. So in this stage, what happens actually is that sometimes the container has got a one-line command. It executes that command and exits. Okay, so once it exits, it gets terminated. So the pod gets terminated successfully. There's no error. It's just that your container, what it did is it executed whatever command it was asked to. Once that command is being executed, its work is done. Mostly this happens in case of cron jobs, or let's say if you want to take any backups, if any report needs to be generated. In those cases, it generally is this is the scenario that's what happens. Okay, so in that case we get this particular status of succeeded. Okay. Now there is another stage that is known as failed. This is quite obvious, right? So when your container exits but it returns a non-zero code, it exits due to some sort of a failure or some sort of an error, right? Then in that case it fails. There can be multiple reasons for this failure. Okay. Now another stage is of unknown. So this is a scenario when your K8s cluster is not able to get the information from the node and hence the pod. So it is not able to connect to the node. The API, the Kubernetes cluster API is not able to connect to the node. Then in that case, the cluster has no clue about what is happening with that particular node, and hence the pod that is running on that node is also not accessible, and hence we don't understand the actual status of it, and hence it goes into an unknown stage. Okay, so this was all about the pod lifecycle. I hope this was clear. This was very easy also to understand, so nothing rocket science in this, right? Now we are going to do hands-on. Okay, but before that, we'll first try to understand the two different ways of deploying our objects on Kubernetes. Okay, so you can deploy your objects using imperative way as well as declarative way. So basically, in case of imperative way, you simply run a command, basically a kubectl command. Whereas in case of declarative approach, what you do is you create manifest files. Okay, so what are manifest files? So these are files which define our objects. Like if I want to deploy a pod, then all the information that is related to the pod is defined inside either a YAML file or a JSON file. Okay, so generally I prefer YAML, okay, because it is easy to write and understand as well. But if you want JSON, you can go for that as well. So in this video, we are going to create our pods using both these methods, that is imperative as well as declarative. Okay, and then we are also going to use port forward in order to access this particular pod that we are going to deploy. Okay, so port forward is something that we do on our local machines. We don't do on our production environments. Okay, so this is generally for the testing purpose. Okay, so now let's try to understand how are we going to do it. Okay, so let's get started with that. So we have already set up a Kubernetes cluster using the kind. Okay, so this is already done for us. So if I do kubectl get nodes, you can see all the three nodes over here. One that is a control plane, and we have got two worker nodes over here. So basically, the pods that we are going to deploy will be running on the worker nodes. Okay. So the first thing that I'll try to show you is that kubectl get pods. If I do this, it is going to check the pods in a default namespace. So basically, what is a namespace? So namespace is nothing but a logical isolation of the resources within the Kubernetes cluster. Okay, so basically for dev, QA as well as prod environments, we have got different namespaces. So most of the companies use namespaces to separate all the resources with respect to different environments. Okay, so now we can see we have got a default namespace. So if I do kubectl get ns, you can see all the possible namespaces. But if I simply run any command related to kubectl, it is going to check within a default namespace. So similarly, it is going to check for the pods within the default namespace. So if I do this, I can see that there are no resources, that is, no pods are running currently. So if I want to deploy a pod using an imperative command, so what can I do? So I'll just clear this and execute a command kubectl run nginx. We are going to deploy an nginx container, okay, within our pod. So for that, I just named it as nginx1 hyphen image equals to nginx. Okay, so I'm not using any fancy image as such. I'm simply writing nginx. I can also mention the latest. Okay, even if I don't mention it, it is going to consider the latest image itself. So if I execute this particular command, you can see that a pod has been created, right? So if I do kubectl get pods, now you can see that this particular pod is in the container creating stage. Okay, so it is the stage after the pending stage. Okay, so this stage is also included, but it doesn't come under important stages. Okay, so it doesn't come under the life cycle. Okay, so once it is running, so now you can see that this particular pod is in the running state. Okay, now if you want to see the IP address associated to this particular pod, then how can you check that? So simply kubectl get pods -o wide. So now if you check, you can see that your pod is in this particular 1x1 ready stage. It is in the running state. Its age is 67 seconds. That is, it has been 67 seconds since the pod is up and running. Okay. The IP is this, that is 10.44.2.2. And this is the node. So I already discussed this, right? So it will be running on a worker node. So this is one of the worker nodes among the two of our Kubernetes cluster. Okay, so since others are not defined, it is showing none over here. Okay, so this is how you can get the IP address of your pod. Okay, now sometimes what happens is, let's say there is some error and you want to debug. What you can do is, you can simply do kubectl describe pod, the name of the pod, that is nginx 1, and you get all the details of your pod. So if there is any error, you can see that within the events itself. I'll show you that as well, okay? So first we'll try to create the pod using a declarative way, that is using a manifest file. So for that we'll have to first write a YAML file for that, okay? So let's go to our VS Code and try to write this manifest file for our pod. Okay, so let's go to the VS Code. Now in here I'm going to create a YAML file. Okay, so for pod I'm going to create pod1.yaml file. Okay, so before trying to create a YAML file, let's try to understand few things. Okay, so if I go over here and just execute a command, that is kubectl explain pod. So it is going to give me the details related to the pod object. So basically the kind that we define over here is pod. The version is v1. And within the description it has talked about what is pod. So pod is nothing but a collection of containers that run on a host. This resource is created by clients and scheduled onto hosts, right? So this is what we have studied. So it is the smallest deployable unit and it contains containers, right? Then the important fields within the pod that we need to define while writing a manifest file are mentioned over here, okay? So you can refer this before you actually write your YAML file, okay? So the fields are that API version, you have got kind, you've got metadata, then the spec, that is specifications of the desired behavior of the pod. So you can get the details from these respective repositories within the Git, okay? If you want, you can just go and, read about it, understand it, okay? So these are the four main fields: API version, kind, metadata, as well as spec. So let's write our first YAML file now. Okay, so the first thing that we are going to define over here is API version, which will be v1, of course, for pods. And if I do the same thing, that is kubectl explain deployments, then in that case it will show you the group as well. So while defining the API version, you will have to consider the group as well in case of deployment. But the same thing doesn't apply for pods because there's no group in that case, okay? So over there you just mention the v1, okay? So this is about my API version. Then you have kind, then you have metadata, okay? Then you have spec, that is specifications. Now one by one we'll try to fill all the details. So basically for the kind, you have got pod, since we want to create a pod. And within metadata, we generally define the name, okay, that you want to assign for your pod. So I want to assign it as Nginx pod, since I'm going to make use of Nginx container. So the next thing is about, let's say, environment. Let's consider this as a dev environment. So I'll be defining it as dev. Or yeah, you can consider the development as well, okay? Then I'm going to define containers within the specification. So if I define the containers, see, containers is a list. You can define one or more containers over here, okay? For example, if I say name, you can also define one more where you define the name again, okay? The important stuff, I'm not going to create two different containers over here. I was just trying to show you like how would you define if you want to create two different containers, because you can have multiple containers within the same pod, right? So this is the way that you can do it. So nginx container is something that I would be defining. Then the image that I want to define is nginx latest. Okay. Then lastly, we define the ports. And within that, I'm going to define the port as container port, which is 80. Why is it showing this to me? Okay. Let me check. So it should not be showing me this thing. I will just remove it. Okay. So just ignore this. Yeah. So this is the configuration for our manifest file. Okay. So we define the API version, the kind, which defines what kind of object is it. Is it a deployment? Is it a pod? Is it a stateful set? We are going to learn these things. Okay. So these are different kinds of objects within our Kubernetes itself. Okay. Then we have got metadata. So metadata is something informative that we give to our pod. So we assign the name. Okay. So this is the name that I have assigned, that is nginx pod. And another extra, actually, you can't directly define a label like this. So we define the labels like this. Okay. That was by mistake. Okay. env, and then you have development. Okay. So this is the label that we assign to our pod. Okay. Then we have the specifications, where we have defined the containers, and containers is a list. Okay. So this is the name, that is nginx container. The image is nginx latest, and the port on which our container will be running is 80. That's fine. Okay. Now let's go to our git bash. Okay. If I ls over here, I can see pod1.yaml file. Okay. Now how will I create it? So I can create it using two different ways. I can execute a command, that is kubectl create pod1.yaml. Okay. I can do it either this way, or else I can also just simply kubectl apply. Both the ways are going to work for me. Okay. So apply is generally used when you are updating. Okay. So if you have changed, or let's say image name is something that you have modified, you want to modify the version, okay, of that particular image, then in that case you can go for apply. Mostly whenever you are updating your manifest file and trying to create and try to update those changes on your pod as well, then in that case you can go for kubectl apply. Okay. And if you are newly creating a pod, then you can go for kubectl create. Okay. So apply -f pod.yaml, and you can see that this pod has been created. Now let me check kubectl get pods. Now again you can see this new pod, that is nginx pod, is in the container creating status. Again, if I run it, let me watch it. So basically, if you want to watch what are the stages that a pod is going through, then you can just go for kubectl get pod --watch. So you can see your containers going through multiple stages. You can see them. Now over here you can see that this nginx pod is in the running state, and it's been 44 seconds. since the pod has been created. Okay, it's interesting, right? Yeah, it's magic. Yeah, so now you can see that this pod is in the running state. Okay, now if I want to create some sort of an error, okay, so what I do is I change the name of my image, let's say 123, or let's say make it something different like 98. Okay, now this image actually doesn't exist. Okay, and one more thing I missed to tell you is that this nginx image that we defined earlier, nginx latest, this image doesn't exist on my local. So what my container runtime does is it pulls the image from the Docker Hub on my local machine. Okay, it pulls it and then it executes it as a container within the pod. Okay, so this image must be present in the Docker Hub, right? Only then it is going to execute, otherwise it is going to fail. Similarly, this nginx 98 doesn't exist. And if I'm trying to apply the changes, let's say I'm doing kubectl apply -f. Now the changes have been applied. Now let's see what is happening. Here you can see that there is an error, that is image pull. Why? Because it is not getting that image. Since it is not getting that image in the Docker Hub, it is giving this kind of an error. Image pull back off. And if I want to debug it a bit more, what I can do is I can simply go kubectl logs and the name of the pod. You can see these are the logs that are getting added as the changes have been applied. So you can see that it quit, it started to shut down, it started exiting. So it gracefully shut it down, then exiting gracefully. So what is happening is that it's trying to restart. When it restarts, it fails again. Again it's restarting, it fails again. So I'll show you. Now it's showing me crash loop back on. So basically it is not working fine. There is these many kind of an errors that it is receiving, right? And the worker process is not working fine. So it is going to show you crash loop back off and the container is not going to execute. But if I again go over here and change it to latest once again, okay, and apply these changes, now if I watch it, it is going to go in the running state after a restart. Okay, so it keeps on restarting. When it fails, it restarts again. And if you go for kubectl describe pod nginx pod, you are going to see all the events related to this particular pod. So what happened? First, it was successfully running. But then what happened is that you changed the definition of your container. And then it was showing this kind of an error. It failed to resolve, right? And then back off pulling image. So it tries to restart. And then it goes into back off stage, right? And then again when I configured again, then it started pulling the image and it got successfully pulled, right? and then the container started, right? So this is how things are working. And who is pulling? You can see kubelet is working. Okay, so kubelet present on our worker node is trying to pull the image from Docker Hub, and it is getting this sort of an error. But later it got resolved because I changed the image name which was relevant, right? So this is how the things are happening. Now, if I want to access this pod locally, I want to access it like how I used to access the containers. Similarly, I also want to access the pod just for the testing purpose, may not be in the production, but in the development stage, I may need it, right, to check whether things are working fine or not. Then in that case, what you can do is you can go for the port forward. Okay, so kubectl port forward. Okay, then you mention the name of the pod, that is nginx pod. Okay, followed by the port, that is 8080:80. Okay, so I think we don't need to mention the pod. And now you can see that the port forward has been applied and it is forwarding on this particular port of 8080. So basically 8080 is host port and 80 is the pod port or the container port, right? So on 8080 we are able to access it. Now let's go to our browser, and if I go for 127 and if I search for 8080, you can see that I'm able to access this nginx page, web page, right? Which means that we have successfully deployed our pod on our Kubernetes cluster. So this is something very interesting, right? So yeah, so we are able to access it. Now, if sometimes you may want to go inside your container, your pod, then how can you do that? So for that matter, I'll just close this connection. Okay, just close this. Once I close this, I'll not be able to access it from my local. So basically, port forward is used when we want to access the pod on your local machine. Okay, so it basically binds the pod with your local host, with the help of which we are able to access it. Okay, so this is what is happening in case of port forward. Now, if I want to go inside my pod, then in that case, how can I do that? So I can just go for kubectl exec -it, the name of the pod, that is nginx pod, okay, --, bash. Boom, you are inside the pod. And if you do ls, you will be able to see all the files within your particular pod. Okay, so this is how things work in case of pods. So sometimes you might need to go inside your pods as well. Okay, you can also do sudo apt update -y. Sorry, you may not get sudo sometimes because you're a root user. You can directly just do apt update y. You can run different commands. It's just similar to a Linux machine, right? But it depends on kind of pod that you are running, right? So this was an nginx image, because of which I was able to execute this command. So I think it's a bit clear till now what all commands we have, what are the most frequently used commands. So you will get different kinds of errors as well within the pods, and Yeah, so related to image, related to any kind of an application errors also, and you will have to debug those. So we are going to go through different types of errors as well. We are also going to go through different types of ways of debugging. So if there is any application error, then what steps to take? If there is any image related issue, then what steps to take? So all of that we are going to cover, but you should know the basics very properly. You should understand, you should read more. So I would recommend all of you to go through the documentation as much as possible, because don't rely on ChatGPT, because ChatGPT can cause many kind of blunders. So the most important thing is to refer the official documentation as much as possible. Only refer it. It's a single source of truth for DevOps engineers. Okay, so try to read as much of documentation as you can. We will try to cover as much as videos as we can, and in this way we will be able to cover the Kubernetes, because Kubernetes is not that easy as compared to what containers or Docker is. Okay, they are slightly complex, and enterprise Kubernetes is a way more complex because so many things are involved in it. Okay, so I would say stick to the documentation, keep practicing whatever you have learned. Hands on, doing hands on is very much important. So yeah, and you'll go through it and you'll be able to achieve what you want. So don't worry at all, just enjoy learning, and also try to subscribe to our channel. If you are new to this channel, we bring such kind of content to our channel, and I hope this video was helpful to all of you as well. uh, so if you found it useful, do like, share and subscribe, and also hype as well. Okay, so thank you so much and have a nice day.